see the coefficients of this regression model. So write coef equals to reg dot coef underscore and print them in output. So write coef. Now build your code to see the coefficients and possible error. If we have error, no. If we don't have any error, as you can see, our coefficient that's being multiplied in x to generate y is equal to 640.44. This parameter must be multiplied to x and it's equal to y. Alright, we must measure our accuracy of our model, so we must use R2 as follow to generate R2 score of our model. So write this code, and this code has two inputs, y test and y pred. This code generates R squared error for our output, but it's measure difference between y pred and y test and show us the output of this model. After it, we must define mean square error for our model. So write it, and similar to R2 score, these codes used y test and y pred to generate mean squared error. We can use print function to see them, R2 and MSE. Now you can build your codes to see the R2 and mean square error. As you can see, we have a 50% in R2 score and a huge mean square error here because of this data is a real data, and they have some non-linear properties. We can't use linear regression to estimate the output of this type of data, but for purpose of example and test our model, it's enough, and you can use them to learn linear regression model. So we can use some plot function to see the output in a diagram. So I use a style dot use ggplot, and we can plot a scatter this data plot, sorry, plt dot scatter y pred and y test, and add some color for it. Color equals to green, and add some title for your plot. Title equals to predicted data versus real data, and add some x label for it, x label, and write y pred and y label y test, and finally use plt dot show to to see the plot. After it, build your project to see the output. Alright, we print or plot y-test based on y-pred. This diagram tells something us. If we have a good accuracy, we must have a lot of data in this line, the line with 45-degree slope. But here we have a lot of data, and they have a lot of data here and here. But if we have a good accuracy, we must have them in this line. So we can plot our data, our predicted data, in another plot to see the difference between real data and predicted data, sorry. So you can use scatter again, plt.scatter x-test and y-test, and use a red color for it, and we can use plot function to plot predicted value x-test and y-pred, and define some color for it. For example, blue is appropriate, and define some line widths to see the output clearly. A line width equals to 2, I think is good. And plt.show finally show the output to us. So go to tools and build it again to see the output. Alright, we must close this to see the second. Okay, as you can see, this line go to between our data, and if we have a good accuracy, our data must be closer to this line for better accuracy. In the next lecture, we want to make a more accurate regression model to estimate our output correctly and more precisely. So stay tuned to the next lecture. Thank you.